I want to start today with a bit of a paradox. Usually when we talk about a technological revolution in this field, we picture something massive.
Right, like giant data centers.
Yeah, exactly. Supercomputers the size of a warehouse, cooling systems that sound like jet engines, and energy consumption that rivals small nations.
For a long time, that's been the rule. The era we've been living in has really been defined by the idea that bigger is just fundamentally better.
Right. But today we're doing a deep dive into a technical report from Microsoft that claims the exact opposite, that the next revolution actually fits in your pocket. Literally.
It's a massive paradigm shift.
It is. It's about this model called Phi-3. And I actually have to quote this because when the model was asked to describe itself, here is what it generated. It said, it's like fitting a supercomputer in a flip phone, but instead of breaking the phone, it just breaks the internet with its mighty linguistic prowess.
I love that. That is a surprisingly confident introduction for for a piece of code.
It really is.
But frankly, looking at the data we have in this report, it might not be exaggerating as much as you'd think.
And that is our mission today. We are going to unpack the Phi-3 technical report. We need to figure out how engineers manage to shrink a massive large language model down to something that can run completely offline on an iPhone 14 while still performing, as well as models 10 times its size.
It creates a real crisis of identity for the industry, doesn't it? I mean, for the last 5 years or so, we've been entirely governed by what we call scaling laws.
The idea that you just add more stuff to get better results.
Exactly. The assumption was always if you want a smarter brain, you have to build a bigger head. You need more parameters, more GPUs, more electricity. It was just a brute force game.
And then Phi-3 basically walks into the room and says, actually, maybe you just need to go to a better school.
That is the perfect way to frame it. Really, this report signals a fundamental shift from being compute optimal, where you're just throwing hardware at the problem, to being data optimal.
So it's about the quality of the teaching.
Yes. It turns out how you teach the AI matters significantly more than how physically big the AI actually is.
So let's get into the specs first, because small is a really relative term here. When I hear small language model or SLM, I'm thinking of a glorified spell checker.
Right.
Or maybe the autocomplete on my text app. Are we talking about something more capable than that?
Oh, much more capable. The star of this report, Phi-3 Mini, clocks in at 3.8 billion parameters.
Which still sounds like a massive number.
To a listener, yeah, 3.8 billion probably sounds like a huge number of knobs to turn. But you have to compare it to the giants to understand the scale here.
Like GPT-4?
Exactly. GPT-4 is rumored to be in the trillions of parameters. Even the open source model, Mixtral 8x7b, which is super popular right now, that's roughly 45 billion parameters total. So 3.8 billion is tiny. It's a dinghy compared to an aircraft carrier.
But the report claims this dinghy is keeping up with the aircraft carriers.
It's basically neck and neck. If you look at standard benchmarks like the MMLU, which tests general knowledge and reasoning across dozens of subjects, or the MT Bench Phi-3 Mini is scoring virtually the same as GPT 3.5 and Mixtral.
That is wild to me.
Yeah.
You're getting flagship performance in a package that is, what, less than 10% of the size?
Less than 10%, yeah. And that size difference completely changes where the model can physically live.
Which brings us to the phone test. Because the report explicitly mentions running this on an iPhone 14 with an A16 Bionic chip.
Yeah.
And that isn't a specialized server. That is consumer hardware. That's the phone sitting in my pocket right now.
And that's the real breakthrough. It runs natively. That means you can put the phone in airplane mode, you can hike to the top of a mountain with zero cellular signal, and you can still have a complex, nuanced conversation with this AI.
Okay, but how is the speed? Because usually when you run heavy software on a phone, it feels like wading through molasses.
Yeah.
And the battery gets hot, everything starts lagging.
You'd think so, but they were clocking over 12 tokens per second on the device.
Okay, for anyone who isn't an AI engineer, help us visualize that. What does 12 tokens per second actually feel like?
A token is roughly 3/4 of a word. So 12 tokens per second is faster than most people can read.
Wow.
Yeah, it feels like a natural, snappy conversation. There's no thinking wheel spinning for 10 seconds while it crunches the numbers. It's practically instantaneous.
And this is where I really need you to explain the magic trick. How do you fit a brain that smart into a phone's memory? The report mentions something called 4-bit quantization.
Right. This is a crucial concept for understanding how they pulled this off. Think of a high-resolution photograph you took with a professional camera.
Okay.
It takes up a ton of space on your hard drive, right? Because it captures every tiny nuance of light and color.
The file size is huge.
But if you want to email that photo, you might compress it into a JPEG. You lose a tiny bit of detail, maybe a pixel here or there isn't mathematically perfect, but the image looks effectively the same to the human eye, and the file size drops by 90%.
So quantization is like the JPEG compression of the AI world.
That's exactly it. Neural networks usually do their math with very high precision. Imagine calculating numbers out to 16 decimal places.
Which takes a lot of computing power.
Right. Quantization rounds those numbers off. It basically says, we don't need 16 decimal places. 4 is enough to get the right answer.
And that shrinks the file size.
Drastically. Phi-3 mini quantized to 4 bits takes up only 1.8 gigabytes of memory.
1.8 gigs. I definitely have games on my phone bigger than that.
Everyone
I
does.
think I have a Spotify playlist bigger than that.
And that's the aha moment for the industry. You no longer need a server farm. You just need 2 gigs of space alongside your photos and your podcasts. It effectively democratizes the technology.
Okay, so we've established it's small, it's fast, and it fits on a phone. But I'm still stuck on the how. You mentioned earlier that we're moving from compute optimal to data optimal.
Yes.
If they didn't make the brain bigger, what did they do with the data to make it so smart?
This is the real secret sauce. Microsoft calls their methodology, textbooks are all you need.
Which implies that the way we were doing it before was decidedly not textbooks.
Precisely. The traditional way to train a model like GPT-3 or the early llamas was the brute force approach. You just scrape the entire internet.
Everything.
Wikipedia, Reddit, Twitter, random blogs, messy code repositories, everything. You feed it the whole mess, the good, the bad, the toxic, the nonsensical. And you just hope the model figures out the underlying patterns.
It's like trying to learn English by reading every piece of paper in a landfill.
That's a great analogy, actually. Eventually, you'll learn English, but you'll also learn a lot of garbage and you'll pick up some terrible habits. It takes a massive brain to sort through all that noise.
So what did Microsoft do differently?
They filtered the web data incredibly aggressively. They threw out the landfill and kept only pages with high educational value.
But the report says they went a step further than just filtering. They used synthetic data,
Yes, they did.
which always sounds a bit like AI cannibalism to me. AI learning from AI. Is that a degradation loop? Like making a photocopy of a photocopy?
It can be if you do it poorly, but think of it this way. Imagine you want to teach a child to solve logic puzzles.
Okay.
You could let them read random internet comments, which is terrible. Or you could hire a professor to write custom step-by-step logic problems specifically designed to teach reasoning.
So they use a bigger, smarter model like a GPT-4 class model to act as the professor.
Exactly. They had the big models generate textbook-quality content, stories, dialogues, and explanations that break down complex concepts into logical steps.
That's brilliant.
They effectively sent Phi-3 to an elite private school where the curriculum was custom-written for clarity rather than letting it learn from the streets of the internet.
That explains why it's so efficient. It's not wasting neurons trying to unlearn internet toxicity or figure out bad grammar. It's only seeing high-quality logic.
Right. But, and this is but there's a trade-off. You cannot shrink a model this much without giving something up. And the report uses a really brilliant analogy involving the Premier League to explain it.
I love this part. It really visualized the problem of capacity for me.
Think of the model's brain as a bucket. A 3.8 billion parameter bucket is relatively small compared to the swimming pool of GPT-4.
Right.
If you fill that small bucket with facts like the score of every Premier League game from the last 10 years or the cast list of every movie ever made you fill up the bucket very quickly.
Those are hard facts.
Yeah.
Arsenal beat Chelsea 3-1. That takes up hard space in the memory.
Exactly. And if the bucket is full of scores, there's no room left for logic. There's no room for the neural pathways that understand how to reason, how to code, or how to write a summary. So the engineers made a ruthless choice. They dumped the facts.
They erased the Premier League.
Effectively, yes. They filtered out specific factual trivia to preserve capacity for reasoning ability.
So Phi-3 isn't trying to be an encyclopedia. It's trying to be a thinker.
That's the critical distinction. It might not know who won the 1998 World Cup, but if you give it a list of player stats and the rules of soccer, it can analyze the strategy better than a model twice its size.
Because it knows the rules of the game, just not the history of the game.
Precisely.
That feels like a fundamental shift in how we should view these tools. We've been treating them like Google, a place to look up facts. But Phi-3 is more like a pocket calculator for logic.
Correct. It's a reasoning engine, not a database. And that design choice is what allows it to be so small, yet so remarkably smart.
Now, the report mentions that Phi-3 isn't just one model. It's a whole family. We have mini, small, and medium. But then there's this sci-fi sounding variant called Phi 3.5 Mo.
Ah, yes, the mixture of experts. This is where the engineering gets really clever to solve the speed versus intelligence problem.
Usually a committee of experts implies slow bureaucracy. How does this work in AI?
So Phi 3.5 MOE is technically a massive model. It's 16 times 3.8 billion parameters.
Wait, 16 times 3.8. That's huge. That shouldn't fit on a phone or run quickly.
It sounds huge. But here's the trick. It doesn't use all of its brain at once. Imagine you have a team of 16 specialists sitting in a room. One is a coder, one is a poet, one is a mathematician, and so on. When you ask a question, a router decides which 2 specialists are best suited to answer. So for any given word, it generates only 2 of the 16 experts are active.
So the other 14 are just sitting there not consuming energy.
Exactly. This is called sparse activation. While the model has a lot of knowledge stored, it only fires about 6.6 billion parameters during inference.
That is wildly efficient. It gives you the knowledge base of a giant model, but the running cost of a small one.
And it punches way above its weight class. The report shows this MOE model beating Llama 3.1 and the Mixtral series on very difficult tasks like coding and math.
Wow.
It's even trading blows with Google's Gemini 1.5 Flash.
Just by being smarter about who answers the question inside the model.
Efficiency through specialization.
Yeah.
And they didn't stop at text either. We have to talk about Phi 3.5 vision.
The multimodal part. This is the one that can see.
It can see, and more importantly, it can structure what it sees. There was a specific example in the source material that really impressed me. They showed the model an image of a coffee shop chalkboard menu.
Oh, you know the type. Handwritten, messy, artistic fonts. Maybe a coffee stain over the prices. The nightmare of traditional OCR software.
Usually OCR just gives you a jumbled stream of text, but Phi 3.5 Vision looked at that messy chalkboard and didn't just read it, it understood the layout.
Really?
Yeah, it converted the visual mess into a perfectly formatted markdown table and even generated the JSON code.
So it recognized the cappuccino was the item. Small, medium, large were the sizes, and mapped the prices correctly.
Instantly, it brings that high-level reasoning capability into the visual world. It's not just saying, I see a cup. It's saying, I understand the pricing hierarchy of this menu, and I can digitize it for you.
I can see the use case immediately. You just point your phone at a chart or a receipt or one of those confusing parking signs and have the AI explain the logic or extract the data.
Precisely. It bridges the gap between the physical world and digital data, all strictly on device.
Okay, I'm feeling very optimistic right now.
Yeah.
I've got a super genius in my pocket that reads menus and solves logic puzzles. But I'm the guy who always asks, what's the catch? It can't be perfect.
It isn't. And to Microsoft's credit, the report has a dedicated section simply titled Weakness. They are very transparent about the limitations of this small bucket approach.
We go back to the Premier League trade-off.
Exactly. Because they emptied the bucket of facts to make room for reasoning, the model has a very low factual knowledge capacity.
So if I ask it a trivia question,
it will likely struggle. The report explicitly mentions it performs poorly on trivia QA benchmarks compared to the massive models. If you ask who was the 14th president of the United States or what is the capital of this specific province in Peru, it might just not have that file stored.
or worse, does it try to guess?
That is the danger. It can hallucinate. There was a really telling example in the report regarding the Winter Olympics.
Walk us through that.
They asked Phi-3 Mini about the 2026 Winter Olympic Games. Now, purely from its internal memory without looking anything up, the model confidently started talking about the game.
It is making it up.
Completely ungrounded, it got the dates wrong, it mixed up locations from Beijing and Pyeongchang. It was hallucinating a plausible-sounding event based on patterns of past Olympics.
So relying on it as a fact book is actually dangerous.
It is. But the report immediately offers the solution, and it's a profound shift in how we design these systems. Search augmentation.
Hooking it up to the internet.
Right. When they connected the model to a search engine, specifically using the Hugging Face Chat UI default, everything changed. It didn't just guess. It used its reasoning capability to query the search engine, read the results, and then synthesize an accurate answer.
So then it correctly identified Milano and Cortina in Italy as the 2026 hosts.
Yes. And this brings us back to that verb versus noun concept.
Verb versus noun.
We need to stop treating AI as a noun. You know, a repository of knowledge. A small language model like Phi-3 is a verb. Its job is to process. Its job is to think. If it needs to know a fact, it should look it up just like you or I would.
I like that a lot. I don't expect my accountant to memorize the entire tax code.
Mm.
I expect them to know how to read the tax code and apply the logic.
Exactly. Phi-3 is the accountant. The internet is the tax code. You separate the processor from the hard drive.
Before we wrap up, we have to touch on safety. Because if I have this reasoning engine in my pocket, I want to make sure it's not a toxic reasoning engine. We've seen small models go off the rails before.
Safety was a huge part of the post-training process here. They employed a technique called red teaming.
Which always sounds like a spy movie operation to me.
It essentially is authorized hacking. Microsoft has an internal red team whose entire job is to attack the model. They try to trick it, break it to make it say hateful things, or get it to give instructions on how to build dangerous things.
And then they use those attacks to patch the holes.
They use that data to refine the model through SFT, which is supervised fine-tuning, and DPO, direct preference optimization.
Got it.
Basically, they teach the model, hey, when someone asks that, don't answer like this, answer like that.
Did it work?
The data shows a massive reduction in harmful responses. You can visualize the bar chart reduction in their report. It's significant. But the experts note a really interesting nuance here, too. It's called over-refusal.
The model becomes a goody two-shoes.
Sometimes, yes. They found instances where Phi-3 would refuse to answer completely harmless questions because it was trying too hard to be safe.
Like what?
Things like deciphering a CAPTCHA or describing an image that looked slightly suspicious but was actually completely fine. Because it's trained to avoid harm, it sometimes errs on the side of, I'm just not going to touch that.
I can't read those squiggly letters. It might be a security risk.
Exactly. Finding the balance between being helpful and being harmless is still an ongoing challenge for the entire industry. You don't want a model that is so safe it just becomes useless.
So where does this leave us? We've looked at the scale, the textbook training, the mixture of experts, and the limitations on facts. What is the big takeaway here?
I think we are witnessing the democratization of high-level intelligence. We've proven that you don't need a supercomputer to have a reasoning engine. You just need better curated data.
It changes the geography of AI. It moves it from the giant cloud to the edge.
It allows AI to live with us privately, right on our phones.
Yeah.
But I want to leave you with a thought about that Premier League trade-off we discussed earlier.
Go on.
We established that to make these small models smart, we had to strip away their factual memory. We had to empty the bucket to make room for logic.
Right, a blank slate of pure reason.
So are we moving toward a future where our best AI assistants technically know nothing? They are just pure processing power. They only know what the world looks like when we connect them to the internet or feed them a specific document.
That is a wild thought. It's almost more human.
It is, isn't it? I mean, we aren't born knowing the capital of Peru. We are defined by how we process information, not by how much of it we store in our heads. Maybe Phi-3 isn't just a smaller AI. Maybe it's a more human-like architecture for intelligence, a brain that needs to learn and needs to look things up.
We are building brains that are purely thinkers and curious rather than just all-knowing databases.
Exactly.
Well, on that note, I'm going to go see if my phone can help me solve the Sunday crossword, but I promise I won't ask it who won the game last night.
A wise choice.
Thanks for joining us on this deep dive. See you next time.